This lesson is on the properties of exponents. So this first slide has the property, the definition, and then some examples off to the right. So the first property is called the product of powers. And the definition has the base is the same. And we want to add those exponents. So you'll see that m plus n. And then there are some examples here. So we have 10 squared times 10 to the fifth. So notice you'll see that we add those powers together to get 10 to the seventh. The next property is called the power to a power. So what we do is we multiply those powers together. So an example of 10 squared raised to the third power, what we do is we multiply that 2 and 3 together, so we get 10 to the sixth power. The next property is called the quotient of powers. So when we divide two exponents, we subtract the powers. So an example of 10 to the fourth divided by 10 to the second, we would subtract those exponents and you get 10 squared. The next property is power of a product. So what you can do is think of this like as a distributed property. You're distributing in to all of the exponentials. So it's x to the n, y to the n. So an example, we have 10 to the eighth and eighth squared. So you're like distributing in here. I'm going to erase that so you can see it. So you're going to get 10 squared and 8 squared. The next property is called the power quotient. So it's very similar to the last one. You're distributing in that power to both of the quotients. So 8 fifths raised to the third power, we distribute that power into both parts. So 8 cubed divided by 5 cubed. The next one is power of 1. Anything raised to the first power is just itself. So 8 to the first is just 8. Power of 0. Anything raised to the 0 power is 1. So x to the 0 power is 1. 11 to the 0 power is 1. The last rule is called the negative exponent rule, and I put these in two separate examples here. So the first one is b to the negative m, and what happens is it flips down. The second one, it's going to flip up. So here's what they look like. 7 to the negative 2 power, what happens is it flips down, and then this one flips up to the numerator. This one again flips down, flips up. All right, so now I have some examples for you to complete with me with those properties. So the first property that we'll tackle is the 0 exponent. So I have that property off to the left and then some templated examples for us to complete. So the first example here, 13c k to the 0. So that exponent of k to the 0 right there, that's just going to be replaced with the number 1. So 13c and then the number 1. And then we just reduce that. So 13 times c times 1 is just 13c. The second example, notice all of this is raised to the 0 power. So anything raised to the 0 power is 1. All right. The next examples, I have 4 of them. They are the negative exponent rules. So here's our rules again, the properties. The first example, we have that negative exponent right here. So that's going to flip down. So that's 5. It's going to stay in the numerator, and then the x to the fourth is going to flip down to the denominator. The one right below it now is going to flip up to the numerator. So it's going to be 4y squared. It's flipping up. All right, this one here is going to flip down and flip down. So the 2b to the 5th will stay up in the numerator, and then down in the denominator is going to be a positive a to the 1st and c to the 7th. Those will become positive. All right, and again, I'm just gonna put a little dot next to the 2 that I'm moving, the b and the x. So the 7, a to the 4th is staying in the numerator, and I'm gonna move that x to the -3 up to the top, to the numerator. And then down below, the y to the 8th is staying as it is, and that b to the 9th is coming down below. So b to the 9th. And we tend to write our exponentials in alphabetical order. So notice that I have an a and then an x and then a b and a y. That's just kind of the typical way we write our exponentials. All right. On my next slide here, I have the product of powers. So we have our rule and then some examples. So I have an x to the 1st, an x to the 6th, and an x to the 3rd. So what we do is we just add all those exponents. So it's 1 plus 6 plus 3. And that's going to give us x to the 10th. The next one, I'm going to just go ahead and rearrange the terms first. So I have -5 and 3. Those are alike. Those are our coefficients. And then I'm going to put our exponentials that are alike. So I have x to the 1st and x to the 4th. And then I have y squared and y to the 6th that are alike. And I'm going to go ahead and add those exponents. Notice those bases are the same. The x's are the same and the y's the same. So we add those exponents. So now -5 times 3, those coefficients become -15. Add the exponents, x to the 5th, and then y to the 8th. All right. Here's our quotient powers. So we have an a to the 9th and an a to the 3rd. So one thing you can do is you can go ahead and just subtract them if we wanted to. So 9 minus 3 is 6. So 9 minus 3 is 6. Or we can think of this as how many can we cancel in common? So there's 9 up here. So I'm going to cancel 6 of those out, or sorry, 3 of those out. So I now have just a to the 6th left. And I'm going to cancel 3 of those out. So now that just becomes a 1. So you're reducing by a common factor. So I'm just going to kind of off the side here something like this. So if I have let's say a 10 divided by 2 and you want to reduce by a common factor, you'd reduce this by a 2 and that would make that a 5. Reduce this by a 2, that would make that a 1. So that's what I did over there in the pink. Now again, I'm going to go ahead and continue reducing. I'm going to reduce this by a common factor of a 2. So that becomes a 1 and a 2. So our final answer then is a to the 6th divided by 2. All right. Next example to the right, we have a common factor of 5. So I'm just going to reduce those by 5. So I'm left with a -3 in the numerator. And then notice there are 4 a's in the numerator and 12 in the denominator. So what's the greatest in common? That would be 4 of them. So that a to the 4th is going to become a 1. And I'm going to cancel 4 a's out there. So that's going to become a to the 8th. So our final answer then is -3 divided by a to the 8th. All right. Next one. I'm going to reduce by a 4, a common factor of 4. So that becomes a -3 and then a 1. Now look at the a's. There are 5 a's and 7 a's in the numerator and denominator. So I'm going to reduce by a common factor. So the common is there's 5 of them. So I'm going to cancel 5 here and 5 there, so there's 2 left in the denominator and just a 1 in the numerator. The b's, 3 on the top and 1 on the bottom, so I'm going to cancel a common factor of 1. So I have a b squared up in the numerator. The c's, I have a c in the numerator and 5 of them in the denominator, so common factor would be a c. So I have 4 c's left, so I'm reducing by. So what's left is negative 3b squared over a squared c to the 4th. All right. Now, let's say you don't like the common factor method and you want to use these properties instead and do that subtraction method. I'll do this in a different way just so you can see, okay, I don't like the common factor method. I'm going to do this subtraction. Here's what you do. So what you look at is the a's. So you're going to go a, you're going to go negative 4 minus 2. And then you're going to do the b's, 7 minus negative 7. And then you're going to do the c's, 9 minus 9. You do that first. So you're just doing your rule. And then you simplify those exponents. Negative 6, that becomes an addition symbol, and you get b to the 14, and then this becomes c to the 0. The next thing then you have to do is you have to look at any properties. This number here has to go down to the denominator because of the negative exponent, and this becomes a 1. So what's left is b to the 14 divided by a to the 6th. All right. Next is the power of a power. So we're going to go ahead and just multiply these two together. So we're going to get 2 to the 6th. And then we can just go ahead and enter that into our calculator. These two, we're going to go ahead and just multiply those powers together. And we get m to the 18th. These two again, we're going to multiply. We're going to get 2 to the 18. We're going to multiply and get negative 6. The problem is we never want to leave an answer with a a negative in the exponent. So we do have to use our negative exponent rule and flip it down. So now that's negative. Turns that to a positive. Power of product, we're going to distribute. So this is going to multiply into here. So it's going to be a to the 6th, b to the 3rd. We're going to distribute 2 to the 5th. Now we're going to multiply. 3 times 5 is 15. And then 2 to the 5th is 32. X to the 15. We distribute in negative 5 to the 4th, x to the 20th, y to the 4th, z to the 8th. I'm going to just type this into my calculator here. Positive 625, x to the 20th, y to the 4th, z to the 8th. We're going to distribute in 4 squared, 3 squared, or you can multiply these two numbers first together, which I think that's the faster way to do that, instead of distributing. Oh. And you get 144. Power of a quotient. We're going to distribute the 4 in, so you get 2 to the 4th, over 3 to the fourth. And then we type that into our calculator. 2 to the fourth is 16. 3 to the fourth is 81. Distribute that squared in. 4 squared over 7 squared. 4 squared is 16. 7 squared is 49. Distribute that squared in, so we get 2 squared, x cubed squared, so we multiply, y squared, z squared. And then we do have to simplify that squared, so that becomes a 4. X squared cubed, that becomes x to the 6th, x to the 3rd, y to the 9th. Now notice we have to do one more thing. These are alike, so we have to reduce those. So we're going to subtract them or reduce by a common factor. And I like the common factor method. So how many do I have in common in the numerator and denominator? I have a maximum of 3. So this becomes now reduced down to x to the 3rd, and that just becomes a 1. So final answer, x to the 3rd over y to the 9th.